Chemistry, equilibrium. Given two equations, this equation here and this equation here, and given their respective equilibrium constants, here's one and here is the other, how do you get Kp? So how do you get the equilibrium constant for this equation? So notice that this new equation, NOBR is the same as up here, and BR2, same there, and NO eventually will be here. So all you need to do to the first one is multiply by 2. We'll get it in a similar format. If you multiply by 2, you're going to get 2NO, and I'm going to leave the phases out right now, plus 2 times 1/2 is 1, so this is just 1 BR2, and that gives you 2 NOBR. And what we did there was we doubled it, so 2 times. We're just going to say that here. Now we need to get to this. So if you notice, this third one over here has an NO, and this one has an NO here. So what we're going to do is we're going to flip. We're going to flip this one around, so we're going to invert it. And when we invert it, we're going to have 2NO on the right, and we're going to have N2 plus O2 on the left. And I'll put a line over that. If you sum them up, notice that the 2 NOs cancel out, 2 NOs cancel out, and that gives you this equation. So you got N2, our destination equation, O2, O2, the BR is going to be here, so we got BR2, BR2, and we have 2 NOBR, and there's 2 NOBR. Now what we did here is we inverted it, so remember you have to invert it like that. So so Kp, our new equilibrium constant, we'll call that Kp double prime, actually, and we'll call Kp the second one over here just single prime, and that's equal to you multiply both of them and what you did to them. So for the first Kp, you multiplied by 2, so because you did that you have to square it, so you're going to square that. And for Kp prime, you inverted it, so you have to invert Kp also. So Kp prime gets inverted. Work that out, and that's your answer.